Okay, so here is an example of a machine that we're going to solve. And what we're trying to do is figure out what force is actually being applied at cable C here. These are cable cutters. So what kind of force am I getting at C? Knowing I'm putting 100 newtons of force at the handles. Okay, so I'm transmitting that force, altering that force, and hopefully getting a much larger force at C to help me cut through the wire that I've got. So what I'm going to do here is I'm going to break it up into pieces. And you start generally with the piece with the force you're trying to find in it, which is basically C. So I'm going to draw this top piece here, right here. So I have the force at C, which is what I'm trying to find. Then I've got the force ED. I recognize that member ED is a two-force member. Okay, so I know the force of this is directed along member ED. So I just draw that straight down as I have there. Okay, so I know the direction of that force because it's a two-force member. Now, at A, I have a pin here, but of course that's connected to a 1, 2, 3 force member. Okay, so I don't know the direction. It's a pin, so I'm just going to draw AX and AY. Again, unknown. Okay, so in this free body diagram, I have 1, 2, 3, 4 unknowns. Okay, but I only have 3 equations, so I'm going to need to draw another portion to get enough equations to solve for the unknowns. And now I'm going to draw that top handle, right? So I've got A. I've seen A before. I didn't know what direction it is in, but I can't change now, so I have to stick with what I had before. Knowing Newton's third law, these forces have to be in the opposite direction from what they were on the other body. Every action has an equal and opposite reaction. So AX is to the left here. It's to the right on the other piece. AY is up. It's down over here. Okay. I also have the 100 newtons, the known force. And then I have this force here at F. Okay. And again, that's connected to this bottom handle, which is a 3-force member. So I don't know its direction. I just put in 2 forces because it's a pin joint, like so. Okay, I've added these 2 unknowns, so I'm now up to 6 unknowns. Okay, but I have 2 free body diagrams, so I have up to 6 equations that I can write. Now, I don't want to write 6 equations. I want to be thoughtful about what I'm going to do here. Okay, so generally, what's important is the linking forces, which is to say AX and AY, because they show up. I could have 6 equations that have AX and AY in them. So if I can find, say, over here, using this member, I can find AX and AY, I can plug those in here and figure out FC. Okay? So I got to think about that. So I'm basically, I'm looking for AX and AY, because then I could take a moment about ED, or about point E, excuse me. If I know AX and AY, then I can find FC. Okay. Well, the other thing I noticed right here is, hey, AX, that's the only thing in the X direction on this free body diagram. So the sum of the forces in the X direction tells me that AX actually is 0. I don't have to worry about it. So let's just do that. Let's ignore it. Well, not ignore it, but we've proved that it equals 0 because the sum of the forces in the X have to be 0. AX is the only force happening in the X direction here. So that gets rid of AX for me. Now, if I'm trying to find AY because I ultimately want to sum the moments about E to find FC. If I can find AY, then I'll be good. Okay. Well, AX I know knows to be 0, so the only other unknown I need to find is AY. I can sum the moments about F, getting rid of these 2 unknowns that I really don't care about finding. So if I sum the moments about F, all I'm going to be left with is AY. Okay. Now, I have my moments here, so I have AY and then 20 sine 15 comes from the fact that I've got a 20 millimeter force right here. Okay? So that horizontal distance is 20 sine 15 times that AY. Okay? And that's going to create a positive moment about F. 100, okay, I have to figure out a couple of things. I have this 20 millimeter distance here. So 20 sine 15 times 100. Okay, because basically I need to find up and over. That's what I'm finding. So I need that distance and then that distance. Okay, and that's where the sine 15 times 20 and cosine 15 times 100, because I've got those distances there. Okay, so that's the moment about point F. Recognizing that the only unknown I have is AY. So I can solve for AY, knowing that I have 100 newtons here, and recognizing that the force at F has 0 moment contribution, and knowing AX equals 0, all I've got is AY. AY, the force AY is 7,364. Which means my assumption was correct, that AY is up over here and down over here. Now that I know AY, I can come over here, sum the moments about point E, okay, and basically take 80 times what I know about AY and subtract 30 times my unknown FC, solve for FC, and you can see that I get 19,600 newtons, which is a lot bigger than the 100 newtons over here. So I've increased, I have a mechanical advantage that we say of about 200 times what I had before. Okay, and that's the whole point, is I want to put a small force here on the handles to get a large force here at the thing. Okay, so that's really how we do it. You break it up into pieces, draw enough free body diagrams to solve for the number of unknowns that you've come up with, and then strategically choose equations to get at what it is you're actually looking at. And really, the more problems you can do, the better you're going to be at choosing equations and free body diagrams to get the answer you're looking for.